Welcome to The Explainer. Today, we're going to talk about the single most crucial skill in programming. And here's a hint. It happens before you ever write a single line of code. We're talking about the logic, the thinking behind it all. You might picture them just furiously typing away, all about complex languages and weird syntax, right? But honestly, the real secret weapon, the core of it all, is how they think. It's all about how they plan their attack on a problem.
Yeah, it really all starts with a plan on paper. Seriously, before they even think about touching a keyboard, a great programmer builds a kind of logical blueprint. It's a clear step-by-step plan to solve the problem, figured out completely away from the computer.
All right, so let's get into it. Programming really boils down to problem solving, and there's a simple but super powerful three-step process that happens before you even think about coding. This is how you break down any challenge into smaller, manageable chunks.
Okay, so first you have to really understand the problem. Like, what are you actually being asked to do? Second, you design a logical solution, step by step, on paper. And only then, third, do you write the code. Did you catch that? The coding is the last step. Steps 1 and 2, that's where the real magic happens. Get those right, and trust me, the coding part becomes so much easier.
So that brings up a good question. How do you actually design that solution on paper? Well, let's talk about one of the most powerful tools for visualizing logic, the flowchart. It's basically the blueprint for your solution.
So, what is a flowchart? Well, think of it like a recipes diagram. It's a visual way to map out every single step, every action, every decision, from start to finish.
And to build one, you just need a few key components. You've got an oval for the start or end, a parallelogram for any input or output, like getting data or showing a result. A rectangle is for a process, like doing a calculation. And then you have arrows to show the direction of flow. That's it. These simple shapes are the building blocks for literally any logical process.
All right, enough talk. Let's build one. We'll take a super simple problem. Find the sum of two numbers, A and B. This is a great way to see how all those shapes work together. Okay, check this out. First, you start with an oval. Then you use a parallelogram to get your inputs, A and B. Next up, a rectangle for the process, sum equals A plus B. Then another parallelogram to print the sum, that's your output. And finally, an oval to end. See how clean and logical that is? It's just a perfect straight line from start to finish. Okay, so that's the visual side. Now let's talk about writing logic down using something called pseudocode. This is like the instructions for your blueprint. If the flowchart is the map, pseudocode is basically the turn-by-turn GPS directions. So what is it? Well, pseudocode is just a simplified, plain English version of your logic. It's not real code. That's the key part. It just reads like a set of instructions. This makes it a perfect bridge between the flowchart and the actual code, because anyone, and I mean any programmer, can understand it no matter what language they use. And here's where it gets really cool. Look at this. The flowchart block for input A, B becomes the first line of pseudocode. Input A, B. The process sum equals A plus B becomes the second line. Print sum becomes the third. It's a direct one-to-one translation. Same logic, just a different way of writing it down. Okay, that's great for simple stuff, but what happens when things get more complex? When our problems aren't just a straight line? That's where we need to handle complexity with things like decisions and repetitions. This brings us to a new shape, the decision block, which is a diamond. And this little guy is so important. It's used in a flowchart to ask a question that has a yes or no answer. This creates different paths for the logic to follow, just like a fork in the road. All right, let's try a new problem. Find the minimum of two numbers, A and B. How would we do that? Well, the whole thing comes down to one core question. Is A less than B? The decision logic is super simple. First, you ask the question, is A less than B? If the answer is yes, well, then you print A. If the answer is no, then you print B. See? That one simple question splits our logic into two different paths. This is the absolute foundation of handling complexity. But what about repetitive tasks? Like, what if you had to sum all the numbers from 1 to 100? You're not going to write 1 plus 2 plus 3 100 times, right? Of course not. For this, programmers have a super powerful tool called a loop. So what's a loop? It's just a process that repeats itself as long as a certain condition is true. It's basically saying, hey, keep doing this thing over and over until I tell you to stop. It's how you automate huge repetitive tasks.
Okay, let's bring this all home. We've gone from logic to code, right? We've seen flowcharts, pseudocode. Let's talk about the final takeaway here. So here's the programmer's workflow boiled down. First, you understand the problem. Second, you design the logic using your flowchart and pseudocode. And then, and only then, you write the code. You see, coding is the last step. It's just translating your awesome plan into a language the computer gets.
There's a great saying, if you can solve a problem on paper, writing the code is easy. And that's the whole point. Master the logic on paper, and the code will pretty much write itself.
So here's a little challenge for you. What everyday problem could you map out with a flowchart? Seriously, think about making coffee or deciding what to wear based on the weather. Try it. You'll find yourself thinking like a programmer before you even realize it.